values of h, k, a, and b. And this is the formula, or the standard form, for the equation of ellipse centered at hk, where the major axis is horizontal. And so I've plotted the 2 points here, 4, 2, and negative 2, 2. And the foci are here and here. And I'll make them little dots right there. And the first thing we want to do is figure out where the center of the ellipse is. And that has to be the midpoint joining 4, 2 and negative 2, 2. So the center of the ellipse is, well, if you use the midpoint formula, it's 4 plus negative 2 divided by 2. The average of the x coordinates would be 2 over 1, or 1. And of course, the average of 2 and 2 is 2. So the center of the ellipse is at 1, 2. And now we know what the value of a is, because a is really the distance from the center of the ellipse to one of the vertices along the major axis. So from 1 to 4 is 3. That tells us that a is 3. And of course, this is h, this is k. Well, all that remains is to find b. And we can use that because the distance from the center of the ellipse to one of the foci is 2. From 1 to 3 is 2, or 3 minus 1 is 2. That tells us that c, which represents the distance from the center of the ellipse to a foci, is 2 units. And then we use the formula that for an ellipse, a squared minus b squared equals c squared. And I just remember that formula because the sign between a squared and b squared is the opposite of what's between the two terms for the general equation of an ellipse. So we've got a is 3, so a squared is 9, minus b squared is equal to c squared. 2 squared is 4. So b squared equals 9 minus 4, or 5. So b equals plus or minus the square root of 5. And that is, b represents the distance from the center to the vertices of the minor axis. So that's about 2.2. So a little bit right up in here is where the other vertices would be, or the vertices of the minor axis. So the ellipse looks something like that. We're not asked to graph it, but the equation looks like this: x minus 1, the quantity squared, over a squared, but a is 3, plus y minus k, which is 2, quantity squared, over b squared, well, radical 5 squared is 5, equals 1. There's your equation. Now let's share my screen here for a second and go to Desmos. And here is that ellipse. And here's the center at hk, which is at 1, 2. A is 3. B is the square root of 5. There's the equation of the ellipse. And what you might want to see here is that as I move this point as a point on the ellipse, this distance plus this distance, that is, from a point on the ellipse to one foci is distance 1, the distance to the other foci is distance 2. That distance remains constant. Focus on this capital D here. That's 6. As I move the point around the ellipse, that distance remains constant, and it's actually equal to the value 2a. So you can picture, like if you had a string here and pulled it taut with a pencil and then traced the ellipse, that string would have a constant length. Okay, so that's the definition of an ellipse. It's a set of all points in the plane that are the sum of whose distances from two fixed points called foci remain constant. Okay, so I hope that gives you an idea of how to find the equation of an ellipse. The important thing is to start by finding the center of the ellipse and then go from there. There you go.